Okay, today we're going to talk about the square root method of solving quadratic functions. And we're going to start by looking at these functions here. What do you see that they all have in common?
A squared.
They've got a squared, they've got a, and what are these numbers? What do all these numbers, what are they? They're perfect squares. And then you see these guys down here, and they're a little weird looking, but what are they? They're perfect square trinomials. They multiply out to be perfect square trinomials. So these are all perfect square something or others, okay? So we're going to learn a method that you wish I had taught you before the last test, sorry, but that will help you really very quickly solve these. And there's a couple things we have to understand before we can use it. So first of all, if I look at the first set and the second set, what's different about them? So tell me some things you notice about set A that are not the same about set B.
It's binomial.
Well, these are binomials, right? Well, this one could be a binomial if I set it equal. So these they have two terms. This one and this one would be a binomial if I set them equal to 0. These all have three terms. Or they're a trinomial set equal to 0, or I could turn them into a trinomial set equal to 0. Okay? So this one and this one are set up differently than these two. This one I could solve by factoring, but I'm going to show you a different way. Okay? So the two ways that we've already learned to solve an equation like p squared equals 16, we learned graphing, so we would put p squared in y1 and 16 in y2, and it would graph p squared like this is just a plain old parent function, quadratic parent function, quadratic, and then it would graph y equals 16, so it would graph a horizontal line at y equals 16, and where they intersect right here is my solutions. I have one at -4 and one at +4. Okay, so that's how we did it with graphing. We could have also looked at the table. With factoring, the way we did it was we saw p squared equals 16. We would move the 16 to the left side. This is the difference of two squares, or you'd put it in the box, and then you'd set them equal to 0. You get p equals 4, p equals -4. Okay, so either way we get the same values. Now this third way that we're going to do it is called the square root method. What we do is, if I have a perfect square equals, if I have like p squared equals something, I can just take the square root of p squared and the square root of whatever's on the other side, and that's my answer, okay? So p squared equals 16. If I take the square root of p squared, y'all take the square root of p squared right now in your calculators or with your phone or whatever it is that you have wherever you're watching this, okay? When you put it in, do you get plus and minus 4, or do you just get 4? Do y'all know how to do the square root? Okay, it's second x squared, and then you put the 16 in there. What are you getting? 4, just plain old 4, right? But remember, there's the reason why it's a positive and a -4 is because there's two ways I can get 4. I can do 4 times 4 gives me 16. I can also do -4 times -4 equals 16. So even though we've always, up until now, we've only used the positive root, there's always been a negative root also. Okay, so whenever we take square roots, there's a positive and a negative square root, because I can multiply two positives together to get a perfect square. I can also multiply two negative numbers together to get a positive perfect square. Make sense? So that's why we have positive and negative. And if you notice over here, we had positive and negative. Here we had positive and negative. So this is another way for us to solve those kind of problems. Okay? So I want us to try one. Let's try this first one. N squared equals 100. I'll pause now to give you all time to do it. Okay, so to solve this one, what we would do is I would take, since I have a perfect square on the right, and I don't really care if this is a perfect square, because I have a calculator, so I can actually have it give me some crazy decimal answer. Or I could leave it in radical form, and I'll talk to you about that when we do this one, okay? If I take the square root of this side and the square root of that side, the square root of n squared is n. Now, even though we know there's two roots, we're only going to put positive, negative on one side. We're going to put it on the number side. You see what I'm saying? So what's the square root of 100? 10. But it's plus and minus 10. Now, how many of you are a little freaked out by this plus minus symbol? All that means it's plus and minus. So it's both of them. So that means n equals 10 and n equals -10. That's what plus and minus means. Okay? Now, if I look at this one, I have t squared equals 7. So if I take the square root of both sides, I'm just going to flip it because I like it with the number first. Is that okay? So then I get t equals the square root of 7 plus or minus square root of 7. Or I could put the square root of 7 in my calculator. What's the square root of 7 when I put it in my calculator? Let's say 2.65. It's plus or minus 2.65. Okay? What do we think? Pretty easy? Okay. Let's try one that's a little bit more complicated. Okay, they're still the same thing. They look different. What makes these the same? What do we not see? A B. We don't see a B term. We don't see a linear term. What makes these different is, what makes these okay to use the square root method on is that we don't see a B term. We don't see a linear term. So I see x squared plus 8 equals 33. These are both constants, so I'm still okay. I can subtract 8 from both sides. Somebody tell me what 33 minus 8 is? Thank you. I have x squared equals 25. I still don't have a B term, so I can take the square root of both sides, and I get x equals plus or minus 5. Okay? Why don't you guys try this one? Okay, so what I would do is I would add 98 to both sides. I have 2x squared equals 98. At this point, I don't have a perfect square over here. I can't just take the square root of this because I've got this 2. So I need to divide both sides by 2. That gets me x squared equals 49. Now when I take the square root of that, I get x equals plus or minus 7. Okay? All right, last example is probably the hardest one, but it's still not that hard. Okay? The last example, now this looks different. Okay? So for this one, I have three examples. And what's different about these is instead of having like x squared, I have x plus 1 quantity squared. So I have this whole thing squared. But the strategy works the same. Okay? So I can take, since this is a perfect square, and I don't really care if that's a perfect square, but it is, I can take the square root of this side and the square root of that side. So watch this one. Okay? The square root of x plus 1 squared is x plus 1. The square root of 16 is plus or minus 4. Now, I'm not done because I still need to figure out what x is. So here's what I'm going to do. I'm going to write two equations. I'm going to write x plus 1 equals 4. I'm going to write x plus 1 equals what? Negative 4. Okay, so now I solve. I get x equals 3 and x equals negative 5. And those are my two roots. Okay? You guys want to try the second one, x minus 2 squared equals 8, and see what you get? Okay, when I do this one, all right, so for this one, I take the square root of both sides. I get x minus 2 squared equals the square root of 8. Now, that's not a perfect square. I'm sorry, plus or minus the square root of 8. So what I'm sorry, and that's not squared. So many mistakes. All right, so I have x minus 2 equals plus or minus square root of 8. So I'm going to still set up two equations. X minus 2 equals square root of 8, and x minus 2 equals negative square root of 8. Okay, I'm going to add 2 to both sides. For this one, I get x equals square root of 8 plus 2. For this one, I get x equals negative square root of 8 plus 2.
So if the one that is equal to isn't a perfect square, you don't have to square it or...
Okay, so the question was if the one that you, if the number you get isn't a perfect square, you don't have to take the square root. You leave that up to the answer choices they give you. If they give you answer choices that have radicals in them, you leave them like this. If they give you answer choices that are decimals, then you take the square root. But I usually start like this because then it's easier to go this way to decimal than it is to try to get back. So I usually start off by writing it like this, and then I move if I have to decimal form. Okay. This one here, again, this one looks a little nuts, but it's not that bad because all I'm going to do is subtract 4 from both sides. X minus 3 squared equals 36. And then I take the square root, I get x minus 3 equals plus or minus 6. So x equals 9, and x equals negative 3. And those are my two roots for that one. Okay? All right, so here's like a word problem example that you might see for this. And, you know, it says, a circular tabletop has an area of 1,256 square inches. This can be represented in the following equation. A equals pi r squared. So if I know that area is 1256, then I would say 1256 is pi r squared. Okay? So they want me to solve to find the length of the radius. So I would say 1256 equals pi r squared. Okay? And again, I want radius by itself. This is kind of a literal equation, kind of not. Okay? So it kind of is. So I want to get that. Right now, I want to leave r squared by itself, right? This is just like it's just like this problem here, where I'm trying to get the squared variable by itself. So I divide everything. So they've already started with that number over there, and we're dividing by 2 so that I just have the squared variable. Okay? So I divide by pi. Okay? So I have 1,256 divided by pi equals r squared. And again, I'm going to leave it like this. If I get to the end and my answer is a decimal, well, then I'll fix all this. I'll divide it by pi, and then I'll take the square root. But until then, I'm going to leave it like this. So I have plus or minus the square root of 1256 divided by pi equals r. Now let's think about what this means. They're saying the square root of 1256 divided by pi equals r, or negative square root of 1256 over pi equals r. Which answer's wrong? Why is the negative answer wrong? Because you can't have negative area. What even is that, right? So even though this would be, if all they gave us was this equation and we didn't know what was behind it, remember, the situation is going to create limitations. That's why we have domain, we have discrete and continuous, and that's how we change our domain and ranges with that data type, discrete or continuous. But in this case, this negative answer does not make sense for our real world situation. So if they, instead of giving me an answer that looked like this, they gave me an answer that was in decimal form, I would do 1256 divided by pi, and then I take the square root of that answer. Okay? All right, so let's really quick, the last thing I want to talk about is, can we solve these two using the square root method? Just like we see them? No. Now the first one, I make an argument that we could solve this one because I could divide these by -1 and get x squared equals 3. Take the square root and I get x equals plus or minus 3. I could make an argument for that one. This one you cannot solve using the square root method. Why? Because why? Well, let's think about it. If I divide both sides by -1, I don't know what I just did there, -1, x squared equals -9. Put the square root of -9 in your calculator. And you get what? You get error, non-real answer. We can't do that, okay? So because we can't do that, that's not going to be an option. This is going to be an imaginary number because the square root of a negative number, it so violates the rules of math. We had to create a letter for it. You would write this, again, somebody else's problem, as 3i. Yeah, but again, boo. Somebody else's problem. Okay, so we're not going to do this year. This will be something you do, I believe, in Algebra 2, but we don't do this in Algebra 1. In Algebra 1, we deal with real numbers. We deal with functions. Okay, so this is not something that we would deal with. Okay, get out your foldable, and we're going to do the examples on there. Okay, so you should be on the square root method tab in your foldable. Okay, I'm going to just work through these fairly quickly with you guys, just so that you have them done. But we've already done this type, so they should be pretty easy. Y'all work along with me. Okay, square root of x squared gives me x equals plus or minus 9. And you can write it like this, but I'd prefer that you actually write it expanded. So let's write x equals 9 and x equals -9, or x equals 9 and -9. Let's write it like that, because that way we know, what we're supposed to be getting there. I want you to understand that it's actually two different solutions. Okay. In general, the square root method is going to result in two solutions. There's only a couple of situations where it won't. Okay. What am I going to need to do to solve this one? Add 10 to both sides. So now I have 3x squared equals 15. Am I ready to go?
No.
No, I got to divide by 3 because I just have to have an x squared over there. So I have x squared equals 5. Now I can take the square root. I have x equals square root of 5 and negative square root of 5. Okay? So far, so good? All right, last one. For this one, I have a perfect square trinomial in factored form equals whatever, a number, okay? As long as I have a squared variable on one side and a number on the other, I'm good to go for square root method. So I'm going to take the square root of both sides. I have x minus 2 equals plus or minus 5. So that means I have x minus 2 equals 5. I have x minus 2 equals negative 5. So I'm going to start solving for x. Add 2 to both sides. I get x equals 7. I add 2 to both sides here. I get x equals negative 3. And those are my two solutions. Okay? Now let me show you the two situations where you might have no solution. Okay, so for this one, no solution. Over here, if I have x squared equals negative 36, when I take the square root of both sides, I get an error. My calculator actually says error, unreal answer. That's what my calculator is going to tell me. So no number, so let's write down no number times itself is negative. So we have no real solution. Okay? So your calculator is going to error out. Even your calculator says you can't do this. This is not possible. But it's going to tell you error, unreal answer, because it's telling you the answer you're asking me to give you, it's not on the real number system. That tells you you don't have any real solution. Now this one over here, I could be wrong, but to my understanding, this is the only way that you can get one solution. Okay? If I have x squared equals 0 and I take the square root of both sides, I get x squared equals plus or minus 0. Is x positive or negative? No, x is not positive or negative, so you only have one solution there. What does it look like when you only have one solution? Do we remember? Wow. Okay, so let's just review that real quick, okay? When I have two solutions, my graph is either below the x-axis pointing up, or it's above the x-axis pointing down, okay? So therefore it crosses in two places. If I have one solution, my graph is either sitting on top of the x-axis or it's hanging off of the x-axis. And if I have no real solutions, my graph is above the x-axis pointing up or below the x-axis pointing down, or maybe just not even on our plane, not on our grid anyway, maybe on some other number plane, like the complex number plane, okay? Tomorrow we're going to talk about how we do this when we have perfect square trinomials that are not already factored.